Dr. Johannes Hinckeldeyn is a director of advanced core technologies at the Kion Group. His specialty is on automation topics such as robotics, machine learning, sensor technologies. Before joining Kion in 2023, he was researcher for diverse universities and research institutions, and also had a startup with a focus on exploration of new battery materials. So I'm very much look forward to your talk.
Thank you very much. So I'm coming from the Kion Group. So for those of you who might not be familiar with this brand, so we are basically the world's second largest forklift manufacturers. We are the largest provider of warehouse automation technology. So basically everything which takes place within a Amazon warehouse should be more or less, for some part, from our products. And we are, I would call it more or less, I would not say still traditional, but in the past we were still a traditional steel and iron company. And so this is going to be a very, I would say, applied and industrialized talk. And what I'm going to tell you today is about, first of all, I will show you a few products where we already use AI in. Then I will also look into the products and the research activities we are currently working on. And then I will, in the very end, also go onto a few problems you might already be aware of, but just to let you know what are the most important problems from my point of view, which has to be tackled in order to bring really AI to such a sector as the intralogistics or warehousing industry. So just very briefly, if you're not so familiar with the warehousing industry so far, so today, how is warehousing? So warehousing is a very, I would say, static and very inflexible environment. So we have a lot of automation already in our warehouses, but it's all built for the ideal warehouse. So the warehouse has been built actually around the whole automation solution as they are today. So which means the robots are doing quite specific tasks. They're programmed for. It requires a lot of engineering effort in order to get them running, and then it is still very much coined by manual processes and a lot of manual labor, which we still have in our warehouses. Also in the future, we also want not to have just those we call greenfield warehouse, but also brownfield warehouses, because a lot of our infrastructure has been here for decades and will be still here in the next decades as well, I think so. So we need to have robots which are quite more flexible, quite more adaptive to a certain situation, quite be more autonomous, and we need some kind of a continuous optimization of our problems. And as a company, how we tackle that, in 2020 we started the first research projects working on AI, and it took us a while in order to really get this off the ground. So we formulated an AI strategy, and this year, after almost 5 to 6 years, we came up with the first AI products, and we launched the first AI products, which I will show you in a second. And from next year on, we are trying to go basically, let's say, call all in, but we really try to scale our automation products using AI models and machine learning. And so those are the products, and I only will go into a few examples here, which we are currently having. So we are currently providing an intelligent stationary camera, which I will show you in a second, and also we use AI for as some kind of a driver assistance system for our manual forklifts. In addition to that, we also have intelligent robots, which you will see, and also a live warehouse twin, which I'm not going to in detail today, but just to mention those. So the intelligent stationary camera and the driver assistance systems are the products I'm going to show here. So the AI camera solution, as you will see, it is still very much that you need a human in the loop in order to use this one, but it should enhance the human and the human driver as he's working. So for example, as you can see here, we have a buffer space, and the buffer space is usually unmanaged from a systems perspective. So we use this camera just simply for identifying whether it has already been occupied by a pallet or by a load carrier, as we call it, as you can see here. Another thing is here, as you can see, is the driver assistance system. It's really that you show the driver not just simply where he is going to drive, but also if there is an obstacle in the way. So we use the driver or the human in the loop in order to really see if there is a problem. Another thing we are working on is also something which we call AI-based load quality. So we have an AI model which is coupled to the AI camera so far in order to determine how well the quality of the load carrier is already, and if there's something which has to be done in order to basically put this back into a more proper, state. And of course, as you have seen, we have also an autonomous robot, so which means we basically try to use AI systems, mostly computer vision models, in order to determine the status of objects to be manipulated. Because in contrast, for example, to autonomous driving, we usually try to avoid to bump into any other object, right? So, but for us, it's more important that sometimes we want to actually collide with an object, but only with certain objects, obviously. So not necessarily with all objects, but for this one, as you can see, we try to manipulate the pallet and bring them to somewhere else. And in order to do so, we really need to recognize the pallets, because as you can imagine, the pallets are so diverse, so that we have a lot of Euro pallets, as you might see, but this is only just one piece of load carrier. And if you go to certain manufacturing companies, you will find, let's say, at least a high number of, let's say, double digit to the low 100s numbers of load carriers to be carried around, and everything would be basically to be handled by the HEV or by the autonomous forklift. And this, it's quite an interesting and difficult task, as well as you can see here the stacking, which makes a lot of assumptions, for example, that it really can be stacked onto each other, which is something which cannot be given for any kind of load carrier which you have, because you might have a lot of load carriers where it is not possible to put something on top. So those are the products which we are already having. And in addition to that, we are currently working on how to use large language models and all these kind of foundation models in order to set up our products. At the moment, when we basically commission one of our new vehicles, there's a lot of engineering effort included. So it's always an engineered solution for a particular use case. So we have a lot of software engineering to be done in order to really set up the use case. And this makes the project and also the use case in the very end very expensive, which is obviously not something we are very happy with, and also the customer is not very happy with. So we currently are working on a so-called reasoning agent, and the reasoning agent is basically there that you can program them using manual, just natural language, and then try to set up the whole project, to set up the whole vehicle without having a software engineer on site. So let's say have just a service technician in order to set it up, which would drastically reduce the commissioning effort and also the cost of such a project. And this is just the latest results from one of our simulations. So we are currently trying to test this in practice as well. As you will see here on the down left side, there is a natural language command typed into a prompt, and this prompt is basically translated into a behavior tree, and this behavior tree is then used in order to steer the forklift, as you can see here. So it should basically drive to a pickup zone where the position of the load carrier is not very well defined, but just had to look for the position, had to pick up the load carrier and bring it to the drop-off zone without specifying geometrically where the load carrier should be placed. And as you will see here, it's something like more like I wouldn't say it's not a 100% optimal driving behavior, because it more throws the pallet into the drop-off zone, but it's basically doing what we are intending to do them. So that's something we are actively working on. But my main message I want to convey today is basically that productization, especially of embodied AI, is quite hard. So why is it that hard? So the one thing is, as I mentioned, we have a lot of brownfield areas. We have a lot of very diverse areas, very diverse factories, warehouses, distribution centers, everything. And they are all individual. And the thing is, we always need domain adaptation. And this domain adaptation requires a lot of engineering effort. And if we want to have real automation, really being successful and really cost effective, we need something we need some kind of models which can more or less autonomously adapt to this different situation to avoid any out of distribution problems. Then we've already talked a lot about safety. So safety is good, and I really appreciate a lot of the effort which is put into safe machine learning, safe AI, but from our point of view, only functional safety, or machine learning models are only safe if they can be functionally safety certified. Otherwise, I mean, they can be labeled as being safe, but for us they are not safe because we cannot sell them as safe. So, and combining functional safety together with machine learning is quite an important task for us, because otherwise we will always stick to those products and solutions which I've already shown, and which are more like always needing a human in the loop, being an assistant to a human, or just having, let's say, statistical purposes and these kind of things. And this would be quite sad, I think. Then you should really take into account that for logistics processes, we need a very high level of reliability. So plus 99% would be very important. So let's imagine Amazon would only have 99% reliability in what they are doing. You can imagine that a lot of the sendings will go wrong. So we need to have very stable and very reliable processes in order to do that. And the latest point down there, I think, is also very important, that we have still a lot of legacy infrastructure, which is still out there today. It is, even if we would today start selling, let's say, all the latest models and all the latest hardwares as part of our trucks, we still would have to maintain a lot of the legacy infrastructure using PLCs, having low quality Wi-Fi and everything, and maintain these systems for a long period of time. And this is still the case out there if you go to the factories and warehouses, that really the requirements are quite different to the lab and what you find there. And this is something to be considered, where we need to have some kind of, I would say, cost-efficient solutions in order to really productize it on that. And with this, I already come to an end, and I'm happy to take your questions.
Thank you very much. Do we have any questions? Yes.
Thank you for your presentation. I have a question to using machine learning in your products. Do you use them anywhere except from perception modules, or only in perception?
Not as of now. Not as of now. At the moment, they are mainly around perception, and but this is going to change, I would say so. But at the moment, the perception is one of the crucial and most important tasks for us, where we are currently aiming at. Yeah. But we have been looking into machine learning-based control of mobile robots, for example. But then you can again bump into the problem of functional safety, right?
Other questions? So maybe I have one. I think in smart agriculture, people are, or at least if it's like within like an hunger, people having similar problems or similar applications. Are you kind of, are these systems also used in these type of applications, or are they two different communities? And you would say that maybe the accuracies which you require in logistics are much higher than in other application fields?
I think, or I would say that we have quite a close exchange with the guys from the agriculture community, also with companies who are working on it, like, for example, Claas or Fendt. So we have here and there touch points, I would say, because they have similar problems. Also, there are still some differences. For example, they are very often operate within the open, so they are completely within open space. So localization is not that big of a problem for them, because they usually could just use, let's say, a real-time GPS or something like that. While in contrast, for us, operating in a building is a bit different, I would say. And we are more like manipulating basically what we are doing. So for agriculture, it's more like that you, in a way, you seed stuff or you do things on the field basically, while we are trying more like we are some kind of manipulator, I would say. I would say the forklift is some kind of manipulator, also a bit more constrained in terms of degrees of freedom, and we only have two, not always, but in many cases we have 2 forks, sometimes we have 4 forks, but this is an exception. So the problems are similar, but still a bit different.
Thank you very much. So let's thank the speaker again.